In today's video lesson, I'd like to go through some tips and tricks for trying to do working drawings in Onshape. Once I have my file created, either a part or assembly, I'm going to come down here to the bottom left-hand corner and insert a new element. I'm going to come up to Create Drawing, and for right now, we'll just go ahead and say OK. Once my drawing is created, it should automatically go ahead and open up this Insert or Select Part or Assembly. So right now I could select a part. I could also change it from Part Studio to Assemblies, and it'll show me all the assemblies that I have created. Right now I'm going to go ahead and select the assembly that I've got, and it's going to ask me to place it. As I place it, I get to decide what my parent or front view is going to be. Right now, it's establishing that off of how I've drawn it, whatever work planes I established for my front orientation. So if I want something different, this is a good time to go ahead and change that. I can also see that currently Onshape has chosen a scale that it thinks is appropriate for this sheet of paper. I also know that this sheet of paper by default is an A size, or 8.5 by 11. If this is not the scale that I want, this is also a good time to go ahead and change that. You have a lot of options to choose from, and you can type in your own as well. Once you have a view orientation that you're happy with and a scale, you can go ahead and place your parent view. Once the location of that view has been placed, it then wants to know if you want any other views. I could go ahead and put on a top view, I could put on a right side view, an isometric view, or any others that I want. For right now, I'm going to go ahead and place on an isometric. Currently, it actually wants to know if I want any other views, and I can see that by the cursor that I currently have. But it's actually dropped the parent view as the view that everything is going to be built off of. So if I want any more views, I'm going to have to reselect the parent view, and then I can go ahead and put on another view. I then may decide that that wasn't the correct orientation for my front view. If that's not the correct orientation or scale for my front view, I'm going to go ahead and hit Escape to drop my projected view. I'll go ahead and hit Escape, and that'll drop the Project View tool, and I can go ahead and double-click the parent view. Once I do that, I can make some changes. If I would like to change the orientation, I could do that. If I'd like to change the scale, I could do that as well. And right now I can see that everything's not going to fit on my sheet the way that it is. So I'm going to choose a different front view. I'm going to change my orientation from front to right side. I'll go ahead and select OK, and unfortunately, because I've actually changed the orientation, it really has kind of screwed up the placement of all the views that I've already put on there. So I'm going to kind of reorganize them just a little bit. At this point, I think that my scale is still a little bit too large. I can go ahead and double-click the parent view. And as I do that, I can change the scale of the parent view, and that will change the other ones. Then unfortunately it automatically will put this scale label on all the parts, and it actually doesn't change the sheet scale itself. So I'm not going to do it that way. If I actually want to change everything that's on the sheet, I'm just going to right click on the sheet somewhere and go to Sheet Properties. Once I do that, I can change the scale for the entire sheet, and that's actually where I want to change this. That in turn will go ahead and change the scale for all the views on my sheet and not put that label all over the place. It is acceptable on working drawings for the isometric to not be the exact same scale as the rest of them. The scale is more appropriate for your front, top, right side views, but not really the isometric. If I want the isometric to be something different, I can double click that. I can change the scale from the sheet scale to something else, and then typically go ahead and take off that label. Another trick that I want to show you is how to actually represent your isometric as a shaded view, or to show the coloring that you had in your part view or assemblies. If I go ahead and right click on my isometric, I have one that says Show Shaded View. If I click on that, it'll grab whatever color schemes I had from the assemblies or the parts. So let's go back through the steps. Once I've established my parent view, I can then project out all of my other views, make sure that my scale is appropriate for the sheet and the annotations that I want to add, and then I got to think about if there are any special views that I would like to add to the sheet before I start adding those annotations, just to try to see how much room I'm going to have for all the dimensions and notes and things that I want. The special views that I'm typically going to put on are things like section views or detail views. For this example, you can actually see a detail view and a section view. The section view is the one over here on the right hand side. These are typically done to split open the part or cut open the part so that I can see inside it, and for the majority of the time it's done for clarification to make the parts a lot easier to read rather than seeing a whole bunch of hidden lines that represent things inside the part. A detail view is a zoomed in section of a part, and we typically do that so that it's easier to put on dimensions or easier to read some kind of small detail on an object. So here I have both a section view and a detail view. So let's go through the process of actually creating this sheet. Let's see if we can't go ahead and add the section views and the detail views for this whole cup. I'm going to start off with an insert view and find my parent view. I'm going to decide what scale I'd like the parent view to be at. And I'll go ahead and place the parent view. Now, even though that is the view that I want, it's actually not the orientation that I want. I would like for that parent view to be rotated 90 degrees, either clockwise or counterclockwise. So before I start putting on any other views, I'm going to go ahead and escape. I'm going to double click my front view or my parent view, and I'll get a lot more properties in this view properties box. Here I've got the option to go ahead and change its rotation angle, and I'll just go ahead and type in 90 degrees. If it doesn't go the direction that you want, you can then go ahead and swap it to the opposite direction. So that is now not only the view that I want my parent view to be, it's in the correct orientation. I can now go ahead and project that to make my isometric. Decide what scale I would like the isometric to be. And turn on Show Shaded View. Now, I'm not going to project the right side view. The right side view is a section view. Section views are used to show inside the part, so it's a lot easier to read than seeing a whole bunch of hidden lines that are representing things that are internal. So I'm going to come up here to Section View. In Onshape, this tool is fairly easy to use. All I'm going to do is bring my tool down to the center point and click that. It'll already extend out past the object however much it thinks is appropriate and put those arrowheads on there. And you can see right now that the arrowheads can swap directions. That has to do with which direction I'm placing the view on. So the arrowheads point in the direction of the material that's going to stay. So I'll go ahead and place my right side view as a section view, and I'll put that cutting plane line on there for me. Let's talk about this cutting plane line for just a moment. You can see that it's represented by two dashes. You have a line, dash, dash, line, dash, dash, line, and so on. And a cutting plane line is used for section views to represent where the object is being sliced. In what's now the right side view, you can see these evenly spaced 45-degree angle lines. These are called section lines and represent where the cutting plane cut through the object. The next thing I want to do is put on my detail view or zoomed in view that we use for clarification. I'm going to come up here to my detail view. I'm going to select where I want the center point of the detail view, and that can be complicated to change later. So I'm going to take a best guess at where I think the center point is, and then I'm going to start dragging my circle out. For this example, I want to make sure that I encompass the center point for one of the dimensions I'm going to put on. So I'll go ahead and place it. And you see up here at the top, it has a scale as well, however much bigger you want it to be. Right now it's jumped to 1:1 or full scale. I can go ahead and place that view. You can also see that it's already started putting labels on all the parts. A-A, anytime you see the dashes, is typically talking about a section view going from A to A. And somewhere on the part I can see a circle with a B on it, and for right now it's actually in the middle, and I would like to drag that to the outside so it's easier to find and read. So I'm just going to grab this orange circle and drag it out the other side. This is also how you can change the scale of your detail view. And again, every once in a while as I click on it, if you grab this blue dot to try to move it, sometimes it can be tough to actually relocate or move. If I have to do that, majority of the time, if you're not going to grab it and select it onto something else, it doesn't want to move. So if it's just floating in the middle of something, moving it is complicated. If you actually want to drag it over to a new location, then it's fine with that. But floating detail views, most of the time it's just easier to delete them and put them back on. Okay, so step 1, get my parent view placed. Step 2, check the parent view's orientation and make sure that that's right. And then step 3, put on any specialty views. For this one, we needed a section view and a detail view. The next step is to put on any center marks or center line bisectors. Center marks are done with this center mark tool. Now most software, as soon as you put on a center mark, it'll actually extend out past the object and make this crosshair for you. This center mark will go ahead and identify center points, but really all it does is put that small plus on there for you, which is nice, but I would like for it to go ahead and extend out past the part. We're going to have to do that a little bit differently. So I'll also put a center mark here. What I want is a center mark that actually goes all the way through the objects, that shows that everything is concentric, that all the circles share that same center point. And for right now, I'm going to have to do that with this 2-point center line. I'm going to come over and I'm going to select this quadrant, and the same thing on the other side. You can also see that that's represented a little bit differently. Instead of the line dash dash line, it's line dash line dash line. So center lines are represented a little bit different than cutting plane lines. I'll do the same thing to this part, but rather than just use this 2-point center line, I'll use the center line bisector or the edge-to-edge center line. I'll just click on the top line and the bottom line, and it'll put that on there for me. And the same thing, it's a line of symmetry. It's a center line, or it's an axis line, however you want to try to consider it. But it tells me that this thing is cylindrical or is the same all the way around this line. I'm going to do the same thing up here, but I'm going to go ahead and go back to this 2-point center line, click my center mark, and out here to the edge. I'm going to need that for a dimension. I'd also like to represent that this line here intersects straight at the center mark. So I'm going to do the same thing and click on the end and the center mark, the end and the center mark, and that shows me that all three of those will intersect at the same point. I'll do that for the dimensions that I'm going to put on. Right, and everything that's left is to put on dimensions. The amount of decimals that you allow the dimensions to show is important. I'm going to zoom in this part of the title block, and you can see down here that I have the option to set up tolerances, so that I can say anytime you see 2 decimal places, you can be off by plus or minus a specific amount, 3 decimals and then 4 decimals and so on. So how many decimals you actually show is important for manufacturing and being able to stay within the range of what is acceptable and not acceptable. So as soon as you put on a dimension, by default right now it's going to show 3 decimals. If 3 decimals is not what you want, you can highlight the dimension, click on this little box, and it'll open it up and allow you to change the number of decimals. And I can change that globally for the entire sheet, or I can change it by dimension. So I only want this to represent 4.25, then I can go ahead and select this 0.12 to show 2 decimals. I can also add or take away symbols. Right now it has added the diameter symbol, and I can add any other notes that I want onto there. I can also change its units from inches to millimeters, feet, and inches, and so on. There's a lot of other options that you can set in here that we'll get to later. For this dimension down here, I actually don't want to tell the diameter of it. I want what's called a note or a leader. To be able to do that, I'm going to use a different tool. I'm going to come up here to just the A, and if I just click somewhere, it'll put on a note that I can type whatever it is that I want. If instead I grab the A and I click on the part, it'll actually add a leader to it, or an arrowhead that's attached to a note where I can call out something specific. For this one, I'm going to type in 0.125 thick and typical. Now that's that shell thickness that's around the outside. So it's not actually a dimension, it's a note. For right now, it's kicked the TYP down to the bottom, and I can actually grab this little orange box, drag it out a little bit farther, and allow that to all go on one line. And putting on angle dimensions is the same as it was back in Onshape when you were doing dimensioning. You just click on 2 lines that are at an angle to each other, and it'll put that on there for you. Once you have on all the appropriate dimensions, make sure that you look around the part so that you don't have things overlapping. Extension lines that are crossing dimension lines, make sure you don't have detailed notes running into other things, and if needed, go ahead and reorganize some things to make it easier to read. In this example, you can see that I have a hole node or hole callout for these holes. Instead of using the dimension tool, I actually have a tool for that called a hole callout. If I click on that and then select the hole, it'll grab all the information for that hole, especially if it was a countersink or a counterboard hole. Once the dimension's been placed, I can also come up and click on it, come to the options box, and I can change it around. For this one, I'd like to add space x3 so that I know that there's 3 of those holes and they're identical, rather than placing that same dimension all the way across the page. For this example, I want to show you how to turn on hidden lines, or lines that can't be seen from the face or the direction that you're looking. So once you have all of your views placed, Onshape doesn't turn on hidden lines by default. Hidden lines are lines that are either inside the part or opposite of the face that you're currently looking at, or hidden by the face that you're looking at. So if I come up to like this top view, I should be able to see that there's a post underneath here, and that'll allow me to see where that post is located in comparison to this whole platform. If I right click on it, I have the option for show hidden lines. And if I do that, it will then go ahead and turn on those hidden lines to show me where that post is located below that face. And then the same thing here. I can click on this one, I can right click on it and go to show hidden lines. That'll show me all the edges that are hidden from this specific view. And the last thing that I want to show you is just a reminder how to go ahead and change dimension styles to show feet and inches. So once I go ahead and put on a dimension, and right now I can see that I'm 293.009 inches, and I'd like to change that to feet in inches. If I come to my options window, I can change it from dimension units inches to feet in inches, and then it'll go ahead and simplify that for me. So now I've got 24 feet 5 inches. And hopefully that'll take care of the majority of the things that you'll need for trying to create the working drawings for your mini golf course hole.